Hello friends, we all want to have a stable life. Do you know even elements seek stability? Astonished? Let's explore how elements achieve that. Our objectives are to study valency and valence orbit, the tendency of an atom to complete its octet configuration, and calculations of the valency of an atom and an ion. According to Niels Bohr, electrons in an atom are arranged in a region around the nucleus called energy levels, orbits, or shells. These orbits are represented by letters such as K, L, M, or by numbers 1, 2, 3, and so on. The number of electrons present in the outermost orbit is known as valence electrons, and the outermost orbit is called valence orbit. The elements with completely filled outermost orbits containing 8 electrons are said to possess an octet configuration. Such elements do not combine with other elements easily and hence show very little reactivity. Therefore, they are said to have zero combining capacity. On the other hand, the elements with incompletely filled valence orbits have a tendency to complete their octet configuration by combining with atoms of the same or different kind. This capacity of an atom to combine with another atom is called its valency. Elements combine with other elements by losing, gaining, or sharing their electrons. For example, the electronic configuration of sodium is 281 and that of chlorine is 287. Sodium finds it easier to lose one electron rather than gaining 7 electrons to complete its octet, while chlorine easily accepts an electron rather than losing 7 electrons to complete its octet. The number of electrons lost or gained by an atom to attain stability is called its electrovalency, which is 1 for both sodium and chlorine. On the other hand, consider 2 chlorine atoms having the electronic configuration 287 approaching each other. As you can see, each chlorine atom needs 1 electron to complete its octet. In this case, instead of gaining or losing electrons, both the chlorine atoms share 1 electron each. The number of electron pairs that an atom can share to attain octet configuration is defined as its covalency, which is 1 for chlorine. Thus, the number of electrons gained, lost, or shared to complete the octet directly tells us about the combining capacity of the element, that is, its valency. Let us now calculate the valency of an atom. We will first study elements having more than 4 valence electrons. Consider an atom of fluorine with atomic number 9 and an electronic configuration of 2, 7. Fluorine thus has 7 valence electrons. In order to calculate its valency, the number of valence electrons is subtracted from 8. Hence, the valency of fluorine is 1 for an oxygen atom with an atomic number 8. An electronic configuration of 2, 6. Its valency is given by 8 minus 6, that is 2. Now we will study those atoms which have less than 5 valence electrons. Consider an atom of sodium with an atomic number 11. It has an electronic configuration 281. Thus, sodium has one valence electron. For such atoms, their valencies are equal to the valence electrons. Sodium thus shows a valency of 1. It should be noted that the valency of both sodium and fluorine is 1. But sodium loses an electron while fluorine gains an electron in order to complete their octets. Hence, the valency of sodium is considered to be positive, whereas that of fluorine is negative. Let us now see how the valency of ions is calculated. Ions which carry positive charges are known as cations. Some of the simple cations are Na+, Cu2+, Al3+, etc. Hence, they have valencies of +1, +2, +3 respectively. Ions carrying negative charges are called anions. The examples of anions are Cl-, O2-, etc., showing valencies of -1 and -2 respectively. Moreover, there exists a group of atoms carrying a charge known as polyatomic ions. For example, NH4+, SO4 2-, PO4 3-, etc. They show valencies of +1, -2 and -3 respectively. To summarize, we have studied that the number of electrons present in the outermost orbit are known as valence electrons, and the outermost orbit is called the valence orbit. Elements with incompletely filled valence orbits have the tendency to complete their octet configuration by losing, gaining, or sharing their electrons. This capacity of an atom to combine with another atom is called its valency. By now, you are aware of valency and valence electrons. But how is it used to write chemical formulas? Want to learn a set of rules for writing formulas? Watch our upcoming videos and learn more about them.